To date the sediments that we're extracting the pollen from, we use a combination of dating techniques. Near the surface, we can use radiocarbon dating to date sediments as old as around about 50,000 years. But that doesn't take us very deep in the sediments. And beyond that, we have to use other dating techniques, which can include luminescence dating, which can go back perhaps 100,000 or 200,000 years. And then beyond that, we use changes in the Earth's magnetic field as a guide to how old the sediments are. And if we go back far enough in time, we find that the Earth's magnetic field has periodically reversed its direction. So there have been times in the past when compass needles pointed south, not north. And the last time there was a period when the Earth's magnetic field was reversed, that is, compass needles pointed the opposite way, it was around about 800,000 years ago. And so when we go down deeper and deeper into the sediments and we make our magnetic measurements and we find that point where the magnetic directions that are preserved in the sediment indicate that the field was reversed, then we know we're back 800,000 years. And there were periods before that that were either reversed or normal, as we call the current field direction. And the pattern is well established from work in other places. So we go down, we match the pattern to the known history of magnetic changes, and we can actually put time markers in the core at various intervals. There's a good one at 800,000 years, there's another one at 2.5 million years, and some small and some subsidiary ones in between. So paleomagnetism, the magnetism of the sediments that we're dealing with, is a very good guide to the age when we've got a sequence like this. There are some other dating techniques that we can use to date very old stuff, but the paleomagnetism is our primary guide here. The mineral grains that are in the sediments have come from older rocks, and the dating methods that you apply to various minerals, so if you wanted to date feldspars, if you dated feldspars from the sediments in the lake here, the age would come out as the age of crystallization of those feldspars in the parent rock. And the parent rock around here is 400 million years old. So those dating techniques don't apply to the sediments. The ages that you get from sedimentary grains simply give you the age of the parent rock.